Good morning. This is Mohamed Elschimi, physics teacher. Today we will have a presentation discussing energy, the definition of energy, and the different forms of energy, and specifically mechanical energy. Okay, so I will share my screen right now to watch the presentation. Um, so here is the presentation. Um, so now, mainly energy. We will, through the next few minutes, we will identify several forms of energy, calculate kinetic energy for an object, um, and the work kinetic energy theorem, um, and kinetic and potential energy source, and different types of potential energy. So I know the time is limited, so we'll start right away. Kinetic energy, of course, is the energy of an object due to the object's motion. So kinetic means motion, and of course, energy is defined as the ability to do work. So energy is defined as the ability to do work. Means like think of it as something that is stored energy, and then you use it to make work. Like an analogy, if you eat some food, you get some energy from the food, and then you will be able to move and perform various tasks and work and things like that. And another fact about energy, that is neither created nor destroyed, but can be converted from one form to another. So you cannot create energy from nothing, and you cannot destroy it completely, but it converts into several forms. Like for instance, if something is falling, it has something that we call potential energy due to its position or height, and then when it falls, it moves, so it gains this potential energy, it loses, and then it converts into kinetic energy as it moves and speeds up during fall. And of course, kinetic energy, since it's motion energy, so you expect that it is a function in speed. So kinetic energy is half multiplied by the mass multiplied by the square of the speed. And in fact, is work and energy is a scalar quantity. So kinetic energy is a scalar quantity. It's not a vector, and the unit is joule. We call the unit of energy joule. So here is a little demonstration about two cars of the same mass that are moving and having different speeds. So of course, these two cars are identical. The red car is moving with a higher speed, means it has higher kinetic energy, or has higher energy than the car with less speed. But if we have a truck, for instance, a bigger vehicle, it has more mass, and it's moving at the same speed as the speeding car. Of course, the car with the more mass will have bigger kinetic energy. And then we have the work kinetic energy theorem. And it states that the net work done by all the forces acting on an object is equal to the change in the object's kinetic energy. So the net work done means the work is the force times distance, of course. So the net work done on an object is equal to the change in kinetic energy. And for instance, if I kick a sled and the sled starting moving from rest and gaining speed. So the work I did here, I did a force with the kick, and it moved the object a certain distance. The work done here on the sled is equal to the change in its kinetic energy. So it started from zero kinetic energy and gained kinetic energy as it speeds up. This is a very famous and very helpful rule. So work net is equal to delta kinetic energy. Another example here, if you see this figure, when nailing on a hammer, when hammering a nail, sorry, you're using the hammer to drive the nail into the wood. Here, the work that you're doing is, of course, the force that you apply with the hammer and the distance that it moves, and is equal, of course, to the change in kinetic energy of the nail as it moves through the wood. Okay, I think, well, I have to end this. As I understand it, it's supposed to be about 4 minutes presentation. So hopefully it was helpful and the presentation was elaborative enough. Thank you.